This is a continuation of the video walkthrough for the Math 143 Semester 2 CWI practice packet. We're on question 34. This is a word problem. Following the birth of a child, Mr. Morgan wants to make an initial investment, P sub 0, that will grow to $95,000 for the child's education at age 17. Interest is compounded continuously at 6%. What should that initial investment be? So that's that initial value we're looking for. I'm even just going to call it P for principal, and that's what we're looking for, that initial amount. So such an amount is called the present value of $95,000 due 17 years from now. Okay, what's that present value? Well, we notice that we have that end result, that end amount of $95,000. That's the usual answer to a problem. And of course, that's going to be 17 years later. They're born, and then 17 years later. So our time is 17 years. I should say years, just in case. It says interest is compounded continuously at 6%. So that's a continuously compounded interest. And 6% is the rate. That's 0.06. And since it's compounded continuously, it has to do with that natural number E. And it has to do with what's called the continuous compound formula. And so here is what that formula is. If you remember, it means that our amount is going to equal PERT. P times e to the RT. So that is the equation. E being the natural number E. 2.718281, blah, 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 blah. So we're going to use this equation. Here we go. Let's just plug in our information. The amount is $95,000. The principal, or P, is what we don't know. So I'm going to put just a P there. Times, E is actually a number. E is the natural number. E is approximately 2.718281, blah, 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 blah. It's even more important than pi. E should get its own special celebration day, more so than Pi Day, but pi is delicious. The R is the rate. Notice that's in decimal form, 0.06 times by T is the time, 17 years. And there we go. Well, wait, we really can't just plug this in a calculator because we don't know what P is, but we do know what this stuff is. Here's what I'm going to do. I want to find out what P equals, like this. I'm going to get the letter P by itself. How can I get it by itself? Instead of multiplying with this E craziness, I'm going to divide both sides by that E craziness. So I'm going to divide both sides by e to the 0.06 times 17. Sorry, that's really small. It's hard to see. I'm going to cancel those out. And then P equals this, 95,000 divided by e to the 0.06 times 17. And so now I just need to crunch this thing and figure out what that is approximately. In fact, I bet it's going to be a crazy decimal, so I'm just going to put approximately. Now I just need to go into a calculator, like Desmos, and I'm going to go in here and I'm going to type this in. I'm going to go 95,000 divided by. Now, it knows E as the natural number. In fact, watch this. Before I finish all this, I'm going to go down here and just type E, 2.718281. It's just like pi, only a different number. In fact, here's pi. 3.14159265358 9. Now it rounded, so watch out. It rounded pi, so it probably rounded this one as well. So let's close that out. We need to finish our equation. It's e to the, so get up there in the exponent, 0.06 times 17. Oops, when I hit times, it jumped out of the exponent. I don't want that. I want to be up there. So you know what I should do is I should wrap this in parentheses so it knows I'm doing this multiplication up in there. Parentheses. There we go. That is what I want. It looks like this is my initial investment. I need to invest, let's see, 3, 4, 2, 5, 6. So what is that? 3, 4, 2, 5, 6. Round to 2 decimal places, so let me grab those last 2 decimal places. Oh, it's going to be 0.51, but then a 9 is going to bump that up to 0.52. It's pretty much 0.52. So that's how we round. There is my initial investment. 34, 256, 252. And then if I actually crunch this the other way, if I didn't do the 95,000, if I just plugged in this number times e to the 0.06 times 17, I would get that 95,000, sort of to check. Here's another problem a whole lot like it. Just a similar situation. Let's just use our formula. Of course, like before, I like to list all my information out. I want to make that initial investment. Of course, I don't know what that initial investment is. This time it's going to grow to 60,000. That's my final amount. And then it's going to be at age 17 again. So they can get out of the house and go to school. Interest is compounded continuously at 4%. So again, it's continuously compounded, and the rate is 0.04. What should the child's investment be? Okay, so again, we got to do this formula. It's A equals PERT, P times e to the RT. So our amount is going to be 60,000, and that is going to equal the principal that we don't know times e to the 0.04 times 17. Sorry, that's hard to read. Maybe I should use a thinner pen there. Let's write it a little bit smaller, and we could probably even zoom in a little bit. So that was 0.04 times 17. And of course, like before, we need to solve for the letter P. So we're going to divide both sides by this craziness. And then divide both sides. That's a 4 there. And then so the P is going to equal that 60,000 divided by e to the 0.04 times 17. Of course, I have no idea what that is. I'm just going to grab a calculator and go 60,000 divided by e to the, and I remember last time I need to do parentheses here or else it accidentally jumps out when I do my multiplication, and I don't want it to jump out. I want it to be just like that. And so it looks like it's 30,000. 3,397. So this is approximately 3,397, but I need those decimal places, so let me go back to that. 0.019, so it's going to be 0.02. It was pretty much 2 cents on the end there. And so that looks like my answer. 30,397.02. And there we go for that. All right, going down here to the last pages. This one talks about using a logarithm. In fact, check it out. It's got these two logarithms. Log base b of 27 equals this crazy decimal. All right, whatever. And or using this one, log base b of 52 equals that crazy decimal. We're going to somehow supposed to find log base b of this. What is going on here? Now, of course, I can't type that in the calculator because I don't know what base b is. Here's what I can think about. What does this have to do with those two logarithms? This is the log base b of 27. This is the log base b of 52. This is like a combination of them. It looks like I've divided them. I've taken the 27 and divided by the 52. When do we take a log and do division with their arguments? We would do division if it used to be a subtraction problem. This could be log base b of just the single guy on top subtracting the one on the bottom. So what I can do is I'm going to color code this here. In fact, I'm going to erase these right here because you'll see that if I have a single log here, which will be this guy because he is the one on top, and then I go and take the other log and subtract it, that's going to be this guy, because he is the one that is on bottom. In fact, maybe I should color code this even over here. You can see in this that the 27 is the piece on top, up here, and the 52 is the piece on bottom. So all I have to do, in order to find log base b of the 27 over the 52, all I got to do is do the log base b of the 27 and subtract the log base b of the 52. How might I even do that subtraction? Well, they kind of told me what the value is. Log base b of 27 is 2.377. Then all I got to do is subtract this other log, which is the 52, log base b of 52. And that was just 2.850. So really, if I understand what's going on here, I can just do this value for him and subtract this value for the other logarithm. So really, it's just that decimal subtraction. I could probably just do it in my head, but for ease, let's just go and type it in the calculator. 2.850. And there we go. It's negative 0.473. Negative 0.473. And that's my answer. Negative 0.473. It ended up being simple subtraction. Let's look down here at this one. Similar problem. Let's check out what's going on. In fact, let's color code this. This first one is log base b of 9. The second one is log base b of 10. Is that going to have anything to do with this, with 90? Is there a relationship here? Wait a minute. 9 times 10 is 90. So this is really when I'm trying to do the 90, I'm really doing 9 times 10. That is my problem for 90. So how would I do that? How do you end up multiplying? Well, if you remember, if you have multiplication going on in here, that really came from two separate logs, but adding together. There we go. So if this first one here is the first multiplication piece, like this guy here for the 9, then that would be my first guy. And if the second piece in the multiplying, that would be this guy right here, the 10, that's going to be the second piece. So all I got to do is take those and sort of fill them in. This is really log base b of 9 right there, because it's the 9. It's the 9 times the 10. And of course the second piece is the 10, so that's log base b of the 10. And if I color code them, the first guy, the 9 guy was the yellow, and the 10 came from this guy over here. And of course, all I need to do now is take their actual values. The log base b of 9 was what? It was 1.585. And we're going to add that with the blue guy. And the blue guy, log base b of 10, was really 1.661. So all we got to do is take the value for the yellow one and add it with the value for the blue one. And that's how we can do this sort of squished together multiplication. Of course, I can probably add that by hand or in my head, but let's just go for ease. 3.246, and there we go, 3.246. 3.246, and that's what we would get.